Okay, so today I'm gonna go through some of the problem on the practice exam. For number one, are you guys okay with number one? I hope you have a chance to take a look. For number two, 1F, you won't see that anything like that on the exam. 1F, that's a count. That's a counting problem. How many outcomes are possible when a coin flips 5 times? That's count, but I'm gonna go through it, but it won't be on the exam. Don't worry if you don't get it. If you flip, what the sample space of flipping coin? What is the sample space? What are the possible outcomes when you flip a coin? Yeah, so 2, right? 2, either head or tail, so 2. How many times I'm flipping? 10 times, right? I'm sorry, 5 times. 1, 2, 3, 4, 5. Is the first flip is independent with the second flip, independent with the third flip, yeah? Well, independent, what do we do? Two events are independent. P of A and B equal to, yeah, P of A times P of B. So you multiply them. Well, to the first is to the fifth, right? So that's count, but you don't have to worry about it, not your level. Maybe in next class, two something. Make sure you understand this, okay? I can change this in a little bit. I can change this one right here a little bit. I can test it a little bit different and ask you what is the P of A or B. So this is mean or, and the cup is and, right? And I ask you what is P of A and B, right? I can change it a little bit. It doesn't have to be 2 intersection. It doesn't have to be two separate ones. I can do it like this. So blue is B, black is A. And I can ask you what's P of A or B, or I can ask you what is P of A and B. Make sure you understand those. Yeah, you guys don't have to go in. Okay, let's do number 2. A lot of students on my Tuesday, Thursday class email me about number 2. They don't understand. Okay, AP Statistics. A study is conducted on whether AP Statistics is helpful on preparing students first year statistic outcomes. Did you guys take AP Stat in high school? Yes? No? Okay, no. Okay, one. How do you like it? You don't have to feel, you be honest to me. Yeah. Yeah. We did a survey at U of M and only 5% taking stat course because they like it. The rest because I have to. So don't worry if you don't like it. Mostly people don't. Okay. Yeah. Consider all the students who, what was that? Who took AP Stat and took Stat 101. So AP Stat in high school, Stat 101 at University of Michigan. We have Stat 101 grade of these students, and we have the information on whether they had passed AP Stat. Here are the findings. 20% of students received A in Stat 101. So this one, if I would have simplified, I would say P of receive an A in Stat 101. Of course, I'm just gonna say received A, because I don't have a lot of space here, is 0.2, right? 0.2. I recommend you do that on the exam. I really do. This one, you should do. Probability of someone, of a student, 30% of students pass AP Stat. So P of pass AP is 0.3. Can someone come up with the last one? Can someone come up with the last one for me? P of what? Hint, conditional. P of something given something. Good, very good. P of received A. Everybody see that? If you don't, go ahead and ask. Okay, don't be shy. P of receiving A, given that student has passed AP in high school, is, what do you think, Sean? Yeah. But it's gonna use for on exam. I really recommend you do this, even though I don't rate it, but I think it's more important than the 3 things we did last time. Okay. The study report stated the 2 events receiving an A in Stat 101 and pass AP Stat are not independent. Confirm the result. How do I know? How do I prove something that how do I prove something that independent? Can someone remind me of the two options you have? Just generally, it doesn't have to be in context. Can someone remind me how to prove 2 events are independent? Or just shout out how to prove 2 events are independent? Option 1, which is a lot of people favor this option, which is P of what? Say A and B are your events. You guys worry me. Wednesday is exam. Maybe you're one of those people like, study the last minute. Some people claim they remember better if they study the day before, they forget. It's true, you forget, but when you read again, you remember longer. You will remember when you study close to the exam day, but you forget right after you done the exam. P of A and B. Okay, you guys finished my sentence. P of A and B equal. Yeah, thank you. P of B. And then the second option, P of A given B equal. The first one. Which is you reduce that, you cancel the P of B, it'll be P of A, right? Yeah. If 2 events are independent, it's canceled, so it's just this letter before the line, the vertical line. So you can pick one of those. Right? Sometimes sometimes you can pick which one you prove, sometimes you cannot. Let's see. Okay. All right, what do I have? I have received an A and I have passed AP. I have the right hand side, yes. I'm talking about the first option, right? I have the right hand side, but I don't have the left hand side. I don't have P of A and B. I had to come up with that somehow. You guys remember the additional rule that you guys remember that? Solve for P of A and B, but I don't have the or. I don't have P of receiving A or pass AP. What I have is the conditional one. Let me remind you. Go back to lecture 13 again. I'm not sure you guys remember right here. There's another way to solve for P of A and B instead of that additional rule, right? Remember, you can manipulate the conditional equation, and then you can solve for P of A and B, which is P of B times P of A given B. You don't have to remember that. All you have to do is, I'll show you how to do this. Okay, so let me say what I want. So we're going to use this option right here. This is the first one. Want to show now in context. Want to show that P of A here is going to be received an A. Received an A and what? And pass AP is equal to, oh, I'm running out of space. Is equal to, let me put this down here. Darn it. There you go. P of receiving A and pass AP is equal to P of received A times P of pass AP. So far, so good? Yeah. Do we have P of receiving A? Yes, we do, right? That's why we simplified it up there. We have this one, which is 0.2. And then P of pass AP is 0.3. So 0.2 times 0.3 is what? Oh, well, we'll take care about that later. It's not difficult. We have to come up with the left-hand side, right? So I'm gonna use conditional probability that involve P of receiving A and pass AP. Okay, so I want that one. We need this. Okay, now we find this, the one in blue, right? Okay, so can you come up with something that involved in that using conditional probability? In conditional probability, you have, maybe I'll write it here, P of A given B is equal to P of A and B divided by P of B, right? So that's the numerator, right? P of receiving A and pass AP, so the same thing as P of A and B. So we have to figure out what is P of A given B and P of B. You fill that in for me. So the numerator is going to be P of receive A and pass AP. So what's the denominator and what's here and what's here? What's the question marks? Conditional probability. I need to solve for this. Tell me what should I put here? Not number, you don't have to tell me in number, but tell me in context. P of what? P of what? Good. That's your B, right? P of. Yeah, that's right. P of receive an A given pass AP. Right? That's conditional probability. Right? Okay, do we have the left hand side? The P of A receiving A given pass AP. Given. Do we have it? Yeah, 0.3333 something there, right? 0.333 something. We have P of passing AP, which is 0.3. How do I solve the numerator? This is just simple math here. Now P of, don't write this down. It's on the, just listen to me. You don't have to write this down. P of A, receiving A and pass AP. I want you to listen now so you understand. Is, now I want to solve for the numerator. I want to solve for P of receiving A and pass AP. Oh, this is math. Maya, you want to give it a try? I want to solve, so I have this, I want to solve for the numerator. So what number should I put here? Think of it, I have 7 equal x over 5. How do I solve for x? X equal, yeah, 7 times 5. So this is your x right here. That's your x. Yeah, right, you're right. If you want to simplify it, that's how you do it. So P of receiving A and pass AP, which is your x on the numerator, is 0.3333 and 0.3. Okay. Maybe I'll use black. don't know why it won't work. What do you have? What do I have? Point 0.3. I got 0.0999 instead of. Okay, now that I have the numerator, so that means this part right here, is 0.099999, right? 0.09999. If you take 0.2 times 0.3, what do you have? 0.06, right? Are they equal? No, right? They're not equal. So therefore, they're not independent, which is we confirm with the study report. Right? You will have something like this on the exam. Exactly same thing. The problem extremely very similar. The difference is context, that's all. But make sure you understand it. During the lecture, it's kind of easy for you because it's already have it. I already have it for you. All you have to do is just find it and then put it in the order. But here you have to you missed a piece. You missed that left piece. You have to find it first and then compare. All right, B, if we randomly select a student who received an A in Stat 101, what is the probability they pass AP statistics? Someone tell me the conditional probability here in terms of, so P what? What they asking P? It's conditional probability, right? Given something happened, and then you find the probability of the next event. So if I write in stat term would be what? Mm-hmm. Yeah, pass AP given, receive an A. Now this is different. Remember you have, what do you have here? You have receive, given, pass, right? Now it's flipped. They're not the same thing. They're not the same thing because the condition change. Therefore probability change, right? So this one, if you were to plug into the conditional equation, how would you do this? Something over something. Let me scroll. Yeah, go ahead. Times. Okay, so the bottom is received A. Is that what you say? The bottom is received A. What about the top? Let me scroll up right there. It's not times, right? It's and. Right? And. Remember, they're not independent. Even though we don't know, we don't assume. So this will be what P of what should be up here? Yeah, that is the end, right? Remember A and B over B, right? It's the same thing. Just to put in context, that's all. So pass AP and received A. Receive A. Well, pass AP and received A is the same thing as receive A and pass AP, right? Oh, sorry. Do we have that? Do we have that? Yes, we do, right? We found it up there. A little bit hard to find, but we found it. 0.099999, right? Again, receiving A, pass AP is the same thing as pass AP and receiving A. We found it from part A, 0.0999 divided by received A, which is 0.2. And you come up with the numbers. That's the easy part. Do we have any questions for this one? I did not on the lecture. I did not show you part A per se. I kind of, but not directly. Um, I cannot show you everything. Kind of like remember your first grade, they teach you how to add, but they cannot teach you all possible way of adding, right? You kind of know yourself, like what, like 5 plus 10 later, you know how to add. Like it's just same here. I cannot show you everything. Once you understand it, you kind of know how to manipulate things around. All right. Okay, so definitely that one on the exam. You don't have to write down if you. I think it's better for you to listen. It's on there. You can go home and do it again yourself. I'm not gonna do number 3. Yourself. Same thing with number 4. I'm not doing number 4. I'm gonna do number 5. I'm gonna do number 5. Hospital treatment. Suppose 2 hospitals are willing to participate in an experiment to test new treatment, and both hospitals agree to include 1,100 patients in the study. Because the researchers who are conducting the experiment are on the staff hospital A, they decide to perform the majority of cases with the new procedure. So they're a bit less conservative. Go ahead and take the new drug. They randomly assign 1,000 patients to new treatment, with remaining 100 receiving standard. So they're pretty confident, right? Hospital B, however, is a bit more reluctant to try something new on too many patients. Then they do the opposite. They only agree to randomly assign 100 patients for the new treatment and leaving another 1,000 for the standard. So here is the table. What happened to people after they receive the product, either new or standard? Okay, so which treatment was more successful in hospital A? So P of, say, just P of standard first. You know, how about this? We're gonna say P of, I want to know probability of survive, of dying, someone died. Okay, it's probability of die given standard. Cool, we talk about hospital A here, right? So on the table, what is the fraction here? What is the proportion here? Probability of someone die given the standard treatment. Just look at the table, right? 95 out of 100, right? 95 out of 100. So 0.95. Look, why do I divide it by 1,100? Yeah, we only talk about standard, right? So you given standard, right? That's condition. Given standard. So I don't want everything. I just want the standard rule. So probability of die given new treatment. Let's see, die given new treatment is 100 out of 1,000, which is 0.1. Yeah, so 10%, right? So here is 95%. Over here, 10%. So which one better? Conclude from those two. Definitely new treatment, right? Look like new treatment better. Less people die. So new treatment does better job in hospital A. Okay, that's question A. Question B, which treatment most successful in hospital B? Same thing. It's just now you do hospital B. So same thing. P of die given standard. Well, why don't you guys do that? I'll walk around. Let's see how you guys do. Most people get it. All right, same thing, right? Same thing. P of dye given center in hospital B, dye is 500 out of 1,000. So that's 50%, right? 0.50 or 50%, or just 0.5. And then P of dye given new treatment. Let's see, new treatment, 5 out of 100. So 0.05, which is 5%. So again, less people die, right? So new treatment, do the same thing, new treatment also does better job compared to the standard in hospital B. Okay, so that's so hospital A and hospital B, that's your subgroup, right? And now what happens? See, it asks you to combine the data together. So we're gonna combine it together. Say hospital, hospital. Can't spell hospital, right? Hospital A plus B together. See, how do I want to do this? So here is treatment. Survive, die, and total. On the exam, try to be neat. Don't be like me. Okay, so treatment is either standard or new. Survive of the two. You add it together. Survive the two is what? 105, right? Is that true right there? You just actually have to copy it down. So 105 for the standard. Oh, my bad. Hang on. No. Yeah. If survive for standard is 505. Add over, not add down. 505. So actually you don't have it. And then die is 595. Total. This one total. Oh, total should 0, 0, 0, 11. Right? Yeah, 0, 0, 11. Okay, new for surviving, new is 100 plus 95, 195. And die 900 plus 5, 905. 0, 0, 11 again, should be. So far so good? Yeah. I decided to give you the table on the exam. Just the table, you have to fill in the title. So I'll just kind of give you the structure. So it's neater, but you still have to fill in the hospital A plus hospital B or whatever that is on there. Okay, so now let's see the dying rate together. P of die is what? Let me do in red. Use red. P of die is 5, 9. Still black. 595 divided by 1100. What you got? Oh, sorry. Yeah, P of die given. I should have say, I should have say more. P of die given standard. Given standard. 595 divided by 1100. I got 54%. It doesn't have to be exact, but roughly. Dye given new treatment. Let's see. 905 divided by 1100. Definitely smaller. Something wrong here? Did there something wrong? No. 0.82. So roughly 82%. So what can you conclude here? Stand to do better, right? Less people die. Standard treatment does better job when combined the two data or two hospital. So what is the example of what was this called this? The relationship changing. Remember the helicopter example? It's Simpson paradox, right? Tell me why the Simpson paradox, according to the definition. Why is it Simpson paradox? So let me recap. Part A and Part B prove that the new treatment does better job. Less people die. So yay, new treatment. But when I combine the two data, I have the opposite result. More people die with the new treatment. So this is an example of Simpson paradox, but how would you put it in word? Tell me how you put it in word. Because you put in word. Anyone want to give it a shot? Good. Very good. That's what I want to hear. It's revert or opposite direction, something like that. Because the result from the subgroup. When I say subgroup, I mean hospital A and hospital B separately. Don't write this down separately. You can it's on your Moodle separately. Oh no. Let me see it here. The result of the subgroup has opposite direction or reverse, like Sean said, opposite direction to the result of combined data. Combined data. Another famous example will be education example from University of Berkeley, long time ago, 1975. It was a big thing. Okay. All right. For this one, so you guys okay with the Simpson thing? Simpson data is kind of have a conditional distribution, remember the two-way table from part A, part B, kind of. All right, let them eat chocolate. You read that and you tell me we're not gonna see we have time to outline the design of this experiment. I'm not gonna outline, but you tell me what kind of experiment is this. Maybe we just answer the part A. Actually, put it in the chat privately to me. What experimental design? Well, we have 3 of them. Complete the complete. What is it? Complete. Darn it. Random. A complete randomized design. Complete block design. Block. Is right here. Right here. Yeah. I didn't know how to complete randomized block design and mass pair design. 3 of these. Oh, yeah. So the answer is one of these 3. Question 3. Don't look at the try your best. Yeah. This example is not a good example. I'll tell you why. If it was me, I'll be confused. But it's a practice. On your exam, we're very clear. You're very either one of these very precise. I got from the book. All right, let me see the chat. Okay, Bailey said complete randomized design. Maya, same thing. Sean, same. Elena, same. What about the others? Megan, what do you think? Megan, same. Caitlin, what do you think? Oh, did you put it here? Oh, this is Bailey. I don't see Caitlin here. What did you say, Caitlin? Sorry, I missed it. Same. Okay. Yeah, complete. At the first glance, it is. But I'll tell you why it's wrong. Not wrong, but it's confused. You can remember mass pair design. What does that mean? A unit or a person being measured twice. Same thing here, right? Before and after being measured twice. That's what it will be. It will me. I was confused. Like, okay, I know it's complete randomized design because 20 subjects is either given cocoa pill or placebo. So I don't know which one I'm being given. It's, at least is one side blinded, right? It's a double blind, at least single blind here. But again, the next question say they measure my health before and after, so I'm being measured twice, kind of like your temperature at noon and morning, stuff like that, or your mom height and your height. So yeah, it's kind of confused me, but it is a complete randomized design. But I don't like the next part. It could be mesh pair-ish. On your exam, don't worry, it'll be very clear. Number 7, you do it yourself. If I have time, I'll come back. But let me remind you this. In addition, how to know how to be able to prove two events are independent, you should know that how to prove two events are disjoint. Also, okay, if I can change my question, I can change a little bit. So in addition, disjoint easier. If you ask me, disjoint is easier than independent. All right, so this one, number 8. A player serving a tennis has 2 chances to get a serve into play. If the first serve is out, a player serve again. If the second serve is also out, the player loses the point. Here are the probability based on 4 years of Wimbledon championship. Have you guys watched the movie King Richard? It's a good movie. I like it. Good movie. I play tennis in the summer. So I like that movie. Okay, so probability of serve in. So playing tennis, right? So tennis here. I'll use red. Maybe down here. So I have a player, right? I have 2 chances, either serve in or serve out. Again, don't worry about the probability. Worry about the branches first. If I serve in, what happened if I serve in? Either I win a point or I lose a point, right? So if I serve in, I win a point or lose a point. If this example is easier, if you know for tennis rule. If you don't, maybe a little bit confused. On the exam, don't worry, I'll give you something that everybody knows. If the first one is served out, then what happened? You serve again, right? You serve again. They give you another chance. You serve again. And if you serve again, if you serve in, then either you win a point or you lose a point. If you serve out, then you lose. That's it. It's right there. It say right there. If you serve, if the second serve is also out, the player loses point. I don't know how many points. Maybe I shouldn't say a point. Oh, I already did say that, so never mind. But it could be just points. Then only one choice here. Lose points. I shouldn't say a points. Could be many points. Okay, now we're gonna plug in my probability. What should I put in the first branch? The first 2 branches. And then, yeah, just add up to 1 stuff. And then next, win point given serve in at 0.73. So this one is 0.27, right? This one and this one. Second serve out, first serve. Given that they first serve out, second serve in. Serve in, serve out, 0.86. And then if you win a point, so this is 0.14, right? And then this one. The second serve, given second serve out and first serve in, you win point. So 0.59. So this is 0.41. This one is just 1, right? 1. What did I put 1 there? Yeah, it's 1. Did I do it on the, I don't remember I did it. In the key. Let me double check. Go to again. I don't remember I did it. It will affect the question I'm asking next, but if I didn't, I should have fixed it and then repost it. I didn't. Oh, I serve else. I don't. Okay, serve L. No, I did. Nothing here. So you just lose point. nothing there. Should be. All right, probability. You do the same thing. Probably so 0.59 times 0.73. What you got? Oh, 7. What about second one? Point 1593. Let me make it a little longer, the arrow. And then this one is everybody check, okay? So just make sure we have the same answer. What you got, Maya? Mhm. And last one. Seven, 4. Thank you very much. And don't stop. We have to answer the question, right? The question. What is the question? Probability of win. So P of win. Just add them, the win one. That one. That one. Yeah, that's 2 of them. That's it. So 0.4307 plus 0.2080, 0.6 something. Right. 7, 8, 3, 0.683. I'm sorry, 0.6387. Okay, so those should be easy ones, easy. All right, this one, let me go. So on the exam for this problem, number 7, it's gonna be number 6 on the exam. Remember I say only 7 out of 8. We have 8 here total, but I only picked 7 out of 8. I'm gonna give you in term of count. You won't see percentage like you see here. And the question is similar-ish. It's supposed to be easier. Depending on how you think of it. It's supposed to be easier than this one. I think, in my defense. I would suggest you take a look at the example shopping online. That's chapter 13. Slides. Something similar on exam. Okay. This is good too, good practice. But I'm not gonna go through this. You can take a look at everything on Moodle. Do you have any questions? No? Okay. For the first question, it's gonna be similar. It's same type, same format. Fill in the blank, but it's gonna be different. Okay, not gonna be the same. Actually, very different. But if you understand what here, then you shouldn't be having any problem at all. All right. All right. If no question, I think we can adjourn here. Study well, and then I'll see you on Wednesday here. Okay, we have to come here. I'll provide the paper. You just bring your calculator and pencil and erasers. All right. You too. Bye bye.
Have a good one.
You too. Bye.